We're going to talk about a few applications in capital budgeting. One of the applications is oftentimes we need to select the machines. Machine has a life. They do not last forever. Right? Just like a cars, you need to, after a few years, the car getting really old, you want to decide to get different new ones. So for example, you got two proposals, two machines. Machine A, it will cost more money, and the maintenance is $4 every year after. The machine lasts for 3 years. Machine B, it's cheaper, costs $10 to purchase. The maintenance is $6 every year for year 1, year 2. So as you see, machine A, you have to replace a new one every 3 years, while machine B, you replace every 2 years. So which one's cheaper overall? It's hard to say. Machine A, the total net present value of the 3-year spending is $25.69, while machine B, the total net present value costs $21. So seems like B is cheaper. However, B only lasts for 2 years, so we have to replace more frequently. Right, so we cannot compare these directly because they are different terms. One way we're going to do is we want to figure out what's the annual cost. So if the annual cost, then we can compare annual cost between the two machines. Okay. So we're going to introduce this equivalent annual cost approach. So once we got total cost in forms of net present value, all we need to do is use annuity factor, present value annuity factor, to discount the net present value. So that will give us the equivalent annual cost. Let me show you the example. For the previous examples, the discount is 6%. Machine A lasts for 3 years. So we have to use annuity term of 3 years at 6%. So use the chart I give you guys in the table. You can find out annuity factor 2.6730. So this will give us the annual cost is 9.61. Similarly, machine B, you have 2-year annuity, 2-year terms, to discount by 1.8334. This brings down the annual cost to 11.45. So which one's cheaper? Machine A is cheaper. So which one to pick? Machine A to pick. Okay. So as you see, let's summarize the steps. Step 1, you want to find the net present value for the overall cost, the purchase cost, the maintenance cost, all the costs due to this adoption of this machine. Step 2, find out annuity factor and the discount. So this will give us the EAC. Now, how do we find our factors? We can use appendix table to find the annuity factor, or we can use a financial calculator. All we need to do is use -1 as a per unit for payment, annuity payment. Then for example, for 3-year 10% annuity, we have a 3-year to M, 10 to IY, -1 to payment, we will got annuity factor, use PV. To solve this, EAC use a financial calculator directly. So it's just a given. We're going to set net present value into PV, then use 3-year, 6%, we can compute the payment. So that's annuity payment, means annuity, the annual cost for this machine. So we have 3 approach, appendix, or financial calculator find the annuity factor, or directly use financial calculator to find EACs. Okay, so we're going to do one practice. The company is considering replace a new older machines, so they have different proposals. Here, this machine is one of them. Machine costs $35,000 And it's 5-year straight line to 0, and the salvage value 30,000. The annual pre-tax operating cost is 6,300. Tax 40%, discount 15%. So we're going to find out what is equivalent annual cost for this machine, right? Okay. Now I'm going to address a few things before we start. So when we have the machine, in the previous example, we ignored a few things. When we have the machines, it's a long-term assets. So it's fixed assets. We do have to consider depreciations. If we have depreciation, we have depreciation tax shield. So this will actually affect our operating cash flow. Yes, it's true. Even we have no sales changes, we still sell same set of bowling balls. The adopt a different machine is going to affect the operating cash flow. Why? Because we have depreciation tax shield. So in this case, so we're going to find out the OCF and also find out the ATSV, because we do have machine residual value in the end. So now we follow the standard capital budgeting, find out the net value of this machine. So let's pause. I want you to practice this one, compare for this answer. So let's take a look at how we found out the net value of this machine and EAC. So to do this, first let's figure out the operating cash flow and the salvage value. So the machine will be sold at 30,000. Okay, the tax is 40%. The machine will be depreciated all the way till 0 in year 5. So year 5, the time when we sell the machine, the book value is 0. So that's ATSV. For operating cash flow, remember there's no impact on the sales revenue. We're going to use tax shield. The sales revenue is no sales revenue change, no change. But the operating cost is 6,300. So this we will have to pay tax. And the depreciation as machine is 35,000 over 5 years straight line. This is a tax shield with time 0.4, right? So once we got the operating cash flow and the ATSV machine cost, so we can figure out net present value now. In the end, the ATSV is part of 18,000. We discount by 5-year discount factor. So this gives us a net present value of negative 29,336. And use 5-year term annuity factor, we get EAC is negative 8751. Okay, so let's work on the net present value, use cash flow keys. First of all, let's clear cash flow key, use second, clear work. The initial cash flow is 35,000. Negative, enter. Then go to the first year cash flow is 980. Negative, enter. We repeat 4 years. As the last year, we have 2 things. For cash flow 2, we have both positive 18,000 and negative 980. This last year, last 5 years. So year 5, so we have to use parentheses to add these 2 first before we enter into cash flow 2. So we use 18,000 minus 980. Okay. So you enter this into cash flow 2, then frequency is 1. After that, we press net present value key. The discount rate is 15. Then compute net present value. Okay, so that's net present value. So how do we find EAC? Recall we have different ways. You can find out the factor directly, or we can use financial calculator. Let me show you how we do this use financial calculator. So I'm going to store this number into 1. Now I'm going to use these the keys in third row, time value money keys, to solve annuity payment. So that's our EAC. To do this, I have to use 5, year 5, 15 IY, then enter net present value into PV. So let's do that. 5. Okay. So before we do that, I want you to clear time value money first. Then we do 5 and 15 IY. So recall 1, enter into PV, then compute payment. So we got the EAC of 8,000, negative 8,751.